Okay, so now we're going to talk about independent and dependent events. Okay, two events are independent if the probability of each event does not affect the outcome of the other event. Okay, so they're not related to each other. Does the probability of me being left-handed have anything to do with the probability of it raining today? No, those are independent events. Okay. Okay, dependent events are two events that are dependent on the first affects the second outcome. So it's usually when so this is the probability of me choosing a random student to go to the office. So anyone out here, I say, oh, who wants to go to the office? I send somebody. While they're gone, then I ask, oh, okay, I need another student. Okay, because one left, there are fewer students in the class, so the probability is going to change. Okay, so the first event is dependent, or so the second event is dependent on what happened for the first event. Does that make sense? Okay. So I want you guys to choose A and B, which ones are independent, which ones are dependent. Write down which one you think is dependent, which one is independent. Read the scenarios. Okay, rolling a 2 on a number cube and getting a heads when you flip the coin. Class, is this dependent or independent? What is it, class? Independent. They don't rely on each other. Okay. B, okay, selecting a marble from a bag that contains marbles of 2 colors, then putting the marble aside and selecting a second marble from the bag. Is that independent or dependent? Dependent. Since I've taken it out, now there's less marbles in there. So it depends what I picked out first. Does that make sense? Okay, and probability. The probability of one event occurring when the probability of another event occurring, then a probability of another event occurring. So it's the probability of me choosing a student from the class that is a junior, and then choosing another student at random that is a 16-year-old. There are 2 events. When I'm using the word and, I'm using 2 events. It can be notated like this. Probability of junior with the upside down U and then 16 years old. We will see it in our notes and our homework. Instead of the U, we'll use the and. So you can write in it as the and. It lets me. Okay, complements are 2 properties, 2 probabilities whose sum is 1. There are only 2 possible outcomes. Okay, so a complement can only have 2 possible outcomes. It's like flipping a coin, heads and tails. They are complements of each other because they total, when they add up the probability, they should equal 100. Okay, so now we're going to find the probability of 6 red chips, 9 black chips, and 5 blue chips in a bag. 2 consecutive chips are drawn from the bag without replacement. Find the probability of each event. So we want the probability of blue, and then pulling another marble out and it being, or another chip in this case, and it being blue. So let's start. What are my total number of chips that I have? 6 plus 9 plus 5. There are 20 chips. Okay, so the first time I have 20 chips in my bag. Then I want to pull out a blue chip. There are 5 blue chips, so the probability of me pulling out a blue chip is 5 out of 20. Now I've taken that chip out. So now how many chips are in my bag? I've taken 1 blue chip out. How many chips are in my bag now? 19 chips. Okay, I took 1 out, I put it aside. Now I'm going to draw another one. Okay, if I drew a blue chip to begin with, how many blue chips are left? 4. I want to pull another blue chip. Okay, so that's the probability of each individual. Okay, but I want them both to occur at the same time. To find that probability, I have to multiply them. So when I have the and, it means to multiply. So blue and blue, I have to multiply the two fractions together, the two probabilities. Then you just multiply across. 5 times 4 is 20. 20 times 19 is 380. I plug that into my calculator to find my percent. How often will that occur? Okay, it's 0.052. Does the 2 make the 5 move up? No. I move my decimal over twice, and I get 5%. Okay, when I want two events to occur at the same time, it usually has a really small probability. Because it's basically saying the chance that I'm going to win twice in a row, okay, has a smaller probability. Okay, so if you ended up with 52% as your answer, you've done something wrong because the probability is kind of high for an and problem. Does that make sense? Okay, next one. Probability of black and then red. So we start out with our 20 chips. How many are red? 6. So the probability of pulling a red chip is 6 out of 20. Now I'm going to do my second pull. How many chips are left in my bag right now? 19 again. Oh, I did that backwards, right? Nobody call me out. What am I going to pull first? A black chip, right? So how many black chips are there? 9 black chips. So that should go first because I want to pull the black chip first. Now my second time, I want to pull the red. How many red chips are there? 6. Since I didn't take any away, there's still 6 of them in there. Then you multiply straight across. So it gives me 54 out of 380 again. That gives me about 0.14. Oh, that's interesting. Okay, does the 2 make the 4 move up? No, I move my decimal over twice, and I get 14%. Any questions? We're good? Okay, now we're going to pull 3 chips out. So just like before, we start with 20. There are 6 red. Since I pulled one out, now I have 19 left. How many blue chips do I have? 5. Okay, when I go to pull the third one out, how many chips are in my bag? 18. And now I want to pull out a black chip, and there's 9 of those left. Okay, multiply it all across. Okay, so 20 times 19 times 18 is 6,840. Which gives me about 0.0 0, 3, 9. Does the 9 make the 3 move up? Yes. Move my decimal over twice, and we're going to get 4%. Any questions over that? Okay, mutually exclusive and not mutually exclusive. Okay, mutually exclusive are events that can't happen at the same time. Okay. So mutually exclusive are events that can't happen at the same time. So it'd be like rolling an odd number and a 2. Can I roll an odd number and a 2 at the same time with 1 dice? No, so that is mutually exclusive. Okay, it would look something like this. Here's a circle here. It has an odd number. Odd numbers in it. And then there's this other circle over here with the number 2 in it. They don't overlap at all. They can't both happen at the same time. So that would be mutually exclusive. Okay, if an event can happen at the same time, then it's called not mutually exclusive. So can I roll an even number or a multiple of 3? Yes, I can. I can use the same things at the same time. Okay, so it'd be like having my circle here, even number, and then my circle here, a multiple of 3. So even numbers would be 2, 4, and 6, but 6 is also a multiple of 3. So this would be a over that overlap. Does that make sense? So that would be not mutually exclusive when they both can happen at the same time. A union is an or problem. I want this or that. The union of 2 sets is all of the elements that belong to one or both sets. An example, the probability of me choosing a student from my class that is either a junior or 16. Okay, there's the notation, the probability of junior or 16 years old, or the union of 16 years old. It is anyone who is a junior or 16 years old or both. Make sense? I win no matter what. If any of those things occur, I still win. So this is a higher probability than, say, our and, because I have more chances to win. Does that make sense? Okay. So if on a number cube, the top face is recorded, determine if the events are mutually exclusive or not mutually exclusive, and find the probability of each event. So the probability of 1 or 4 So can I roll a 1 or a 4 at the same time? No, I can't. So this is mutually exclusive. And to prove that, I'm going to write out my numbers. 2, 3, 4, 5, and 6. A 1 is here. A 4 is here. There is nothing that are highlighted in both yellow and blue. So my probability is I have 2 things highlighted, and there are 6 numbers. So that's 0.333. The 3 does not make the 3 move up. So I move my decimal over and I get 33%. Any questions over that? Okay, we want to do the probability of a number greater than 2 or a 6. Can those both happen at the same time? Yes, they can. 6 is greater than 2, so it could happen at the same time. So this is not mutually exclusive. So again, to prove that, I'm going to draw my number line. Okay, a number greater than 2. So 3, 4, 5, and 6 are greater than 2. Or a 6. Since 6 falls into both those categories, that's how I know it's not mutually exclusive. Okay, so what is the probability of me rolling a number greater than 2 or a 6? Very good. 4 out of 6. Which is about 0.666. Does the 6 make the 6 move up? Yes. Move my decimal over twice, and I get 67%. Any questions over that? Okay, you guys do the next one. Okay, Sam, was H mutually exclusive or not mutually exclusive? Very good. Okay. Adrian, what'd you get for your probability? How many numbers were less than 5 or an even number?
2.
Okay, there are a lot of numbers less than 5. There's more than 2. Oh, we're going. Let's try. We're not going to guess. Let's try. 1, 2, 3, 4, 5, 6. Here are my numbers that are less than 5, right? Or now we also have to highlight the ones that are even. So 2, 4, and 6 are even. So how many numbers are highlighted here? There's 5 of them. I got what you mean. Okay. We want just, it doesn't matter how they're highlighted, but we can't go over them, right? It can't be more than 100% because 5 is not going to give me what I want. Okay. So 1, 2, 3, 4, or 6, they all fit into one or the other or both of those categories. Does that make sense? So it's 5 out of 6, which is 0.833. I move my decimal over twice and I get 83%. Any questions over that? Okay, now if I'm given probability that it's, and I tell you it's mutually exclusive, then I can find the or, probability of A or B occurring. So A and B are mutually exclusive. Find the probability of A or B. Okay, so the probability of A plus the probability of B is going to equal the probability of A or B. So when we were talking about and meant to multiply, or is add. You're just combining the two probabilities. So the probability of A or B in this case, this is 30% plus 12%, which equals 42%. That's all I'm asking you to do, is add them. Any questions over that? Now I'm giving this in fractions. So I'm going to add the fractions. 2 over 5 plus 1 over 6. To add fractions, I need a common denominator. What is my common denominator here? 30. So for the 5, what did I need to multiply the 5 by? By 6. If I do it to the denominator, then I have to multiply the numerator also by 6. So that's going to give me 12 here. Okay, how did I make the 6 into 30? I had to multiply by 5. If I do it to the bottom, I also have to do it to the top. 1 times 5 is 5. 12 plus 5 now is 17 over 30. Since they gave us our probability in fraction, I'm going to leave it as a fraction. You could change it to a percent if you'd prefer, but you can leave it like that. You could. Yeah. For K, they gave you a percent and a decimal or and a fraction. I prefer to work